also. Okay. Okay. Yeah. Now it is recording. I will send the today class notes to you. No need to write, just listen. That is more than enough. So what is your topic? In case if you are able to take some few points, hints, then you can note down that. So what is the topic of our subject is the ordinary differential equation. You see your syllabus. The last class I have given the what are the books you have to follow. There are two books are there to follow that. One is Simmons and then one more is Codington. Even one more book is there that will be used in the tutorial only. But we will look afterwards. In the next class, I will give that what is the lecture scheme or lecture plan. So today we will going to discuss only the introduction, nothing else. Then we can take that 2, 3 or 4 classes in the introduction. That is better for you for that the upcoming classes or upcoming semester. Even in the research also, this will be very useful to you. So the topic is ordinary differential equation. So what is the motivation of the ordinary differential equation? So whenever you go through in the real life, that order of change or rate of change, then the ordinary differential equation forms, whether it may be that ordinary differential equation or partial differential equation. Particularly whenever one problem is appear in space or any physical based problems, maximum in our day-to-day life, we are facing the rate of change problems. Wherever the rate of change problems occurs, then we have to compulsory form the ordinary differential equation or partial differential equation. And then what are the situations are there in our real life for that ordinary differential equation? See, that is the first point. The motion of projectile, rocket, satellite, and planets. Second point is the change of current in the electric circuit. So in the electrical and the electronic circuits, whenever that even the computer science students also using that the ordinary differential equation. And then electronic student, mechanical student, particularly when they are studying about the fluid dynamics, they come across that the compulsory they have to study that ordinary differential equation basics. Okay, and then heat conduction problem, heat and mass transfer problem, and then vibration of the wire of the membrane, etc. Compare with that B.Sc students and then the arts and science students, engineering students are much more familiar with that this ordinary differential equation, because whatever the field in the engineering, they come across that the rate of change problem. So they have to study that the ordinary differential equation or partial differential equation. So here the mathematical formulation of such problems, the mathematical formulations of such problems emerge as differential equations under certain scientific laws. These laws involve various rate of changes. Particularly what is scientific laws? There many laws are there. A very famous scientific law is there. Anybody are able to tell me that what is that very famous scientific law? It will be very useful to that all the mathematical or all the physical phenomena. He is a very famous mathematician. Mathematician name, in the mathematician name only the lawyer. Anybody?
Newton's law.
Exactly. Beautiful answer. Newton's law. That maximum of the physical nature of the problem is based on the Newton's law of motion. Newton law of motion. There are three Newton's law is there. Maximum second law is that first law and second law is that very important. Force equal to mass into acceleration. These laws involve various rate of change of that one or more quantities with respect to that other quantities. That thus the scientific laws manifest as mathematical equations involving derivative or differential equations. That is the first slide. Then we come to the next slide. The differential equation emanates from the problem in geometry, mechanics, physics, chemistry, and they are telling that in general engineering studies. See, once again I mentioned that please no need to write the notes, just to listen. In case if I am asking any questions, just to answer them. That is more than enough. Then afterwards, from the notes, I will post the notes. Then from the notes, you can write the notes in the notes. Okay. Then we have studied about rates in our early classes. This is also known as instantaneous rate of change. What is mean by rate of change? Rate of change with respect to, in case I am writing here dy by dx, what is y, what is x? Y and x are variables. What is y, what is x? What is called that x, what is called that y? The 9th or 10th standard we have studied about that what is y, what is x. Very simple. In the
Y is dependent.
Yeah, y is dependent variable.
And x is independent.
Independent variable. Then one more name is there in the set theory. In the set theory, we have studied about this. Why it is right as y equal to f of x. Very simple concept. Actually, here if two sets are there, I'm drawing in that the mouse. That's why I'm not able to draw that very perfectly. In case if it is x, it is called a domain, and then it is y. It is called a codomain or range. There are two sets are there. I am relating the two sets through one function. That is the unknown function f. Okay. So here it is called the domain. It is called the codomain. Actually, what is the function general form? Range. Not able to write that very fast. Writing in the mouse. So range equal to whatever the function of domain. So that's why we are writing here y equal to f of x. What is the range here? Y equal to, it is a very basic one. Function, what is the function here? F, put the bracket. What is domain here? X. That's why it is written as y equal to f of x. It's a very simple concept in that we have studied in that our basic. We give the below some relations between the rate of change and unknown functions that are occur in the real life situations. Some relations. See that what is the implementation of the set theory? The simply implement of the set theory in relation. Then function. Set, relation, function. Then afterwards we can derive many functions, one-to-one function, many-one function, whatever it may be. So here the rate of change of y with respect to x is directly proportional to y. That can be written as dy by dx equal to ky. So the rate of change of y with respect to x is directionally proportional to y. Actually, how can we write that? dy by dx, dy by dx is directionally proportional to y. In case opposite proportional to y or inverse proportional to y, then we have to write that in inverse 1 by y. Like so, see the third one, the rate of change of y with respect to x inversely proportional to y. Then that equation forms the equation form dy by dx equal to k by y. So this is a very simple concept for that the rate of change of y with respect to x is directionally proportional to y dy by dx equal to ky. The second one is the rate of change of y with respect to x is directionally proportional to the product of y square and x. So how can we write that? Dy by dx equal to k y square x. Actually, in general, first order differential equation can be based on what is this? Velocity. And then y equal to some f of x or f of t, then it is distance. The rate of change of displacement is velocity. The rate of change of displacement is velocity. The rate of change of velocity is the rate of change of velocity is please answer.
Acceleration.
Acceleration. So rate of change of velocity, please switch off Mala. Switch off your video. Okay, fine. Now, so in this page, we have discussed about that what is called the differential equation. Very simple differential equation. So these three examples are that very simple example for that differential equation. And then மாலா உங்களுடைய வீடியோ ஆஃப் பண்ணுங்க, எனக்கு டிஸ்டர்பா இருக்குங்க. Okay, thank you. Next one is the rate of change of y with respect to x is directionally proportional to y square and inversely proportional to root x. Then dy by dx equal to k into y square by root x. So the differential equation is an equation in which some derivatives of the unknown function is f. Unknown function is f occur. In many cases, independent variable is taken to be time. So in case if you are writing that y equal to f of x, what is our aim? Our aim is to find y based on x. X is the independent variable. Unknown function is y. So here, in case if you are writing that y equal to, for example, y equal to some x square, I am writing. So how to find that y here? Through x only. If you know that x, then we can find that y. So y equal to x square is an unknown function, but x is the known one. In order to apply mathematical methods to a physical or real life problem, we must formulate the problems in mathematical terms. That is, we must construct a mathematical model for a problem. Many physical problems concern relationship between changing quantities. So when you form the mathematical model, then they keep that changing the quantities, then only we can form the mathematical model. Changing the quantities means rate of change. Changing the quantities means rate of change. Since the rate of change are represented mathematically by derivatives. So whenever that physical problems is based on the change of quantities, the change of quantities is known as the rate of change. When the rate of changes appear in the problem, that the derivatives appear in the problem. So mathematical models often involve equations relating to unknown function and one or more of its derivatives. Such equations are differential equations. It is a very simple definition for differential equation. when the differential equation forms. Whenever you apply the mathematical model for the physical line, that is a real life problem. When it is in the real life problem, we must formulate the mathematical model terms. We must construct a mathematical model for the problem. Many problems concern relation between the changing quantities. So what are the important terms in this page? Changing quantities and the rate of change and then derivative. So that is the evaluation of this problem. They are basic significance in science and engineering since many physical laws as well as relations are modeled in the form of differential equations. So the differential equations are much useful in describing mathematical models involving population growth, changing quantities. I told now. So what is the important term here? Changing quantities, population growth. Population growth means it is always increasing in the either in exponential order or it is usually in that exponential order only the population growth or the radioactive decay. Radioactive decay, that is based on the signals and systems. That is some signal problems or some electronic based problems or that is radioactive decay. The study of biological sciences. The study of biological sciences. Any example for this? Any simple example for this? Padma Priya, can you tell me the answer, simple answer for this? Biological sciences. Many applications are there in the biological sciences. Narmada? Narmada, are you there?
Yes, sir.
Any biological science problem? Simple problem. Any applications you can tell. Bhargavi?
I don't know, sir.
No, that's okay. Anybody can. No, don't think that it is the right or wrong. Whatever that you don't think like that. Okay, whatever you know, you tell me that it may be wrong. You'll correct it. No problem at all. Anybody? Any other? Able to tell Lakshmi? Yeah, ma, they were there. In case if you are attending the class, you don't sit with others. Backside some noise is coming. It's disturbing to me. Please keep it in mind whenever you attend the class. Please you sit alone. Please mute your audio. Okay. Otherwise, I can that study of biological sciences problem. That fluid dynamics. That means in case if you are studying about the heartbeat problem, or blood flow problem, please mute your audio. Biological sciences problem means some heartbeat problem, blood flow problem, or that is urine flow problems, or that biological sciences problem. And the economic is incomplete without application of differential equation. And economics, even economics also the growth rate is there. Growth of economy, that time series problem is that is also based on the ordinary differential equation. So next slide is the subject. The differential equation was invented along with the calculus by Newton and Leibniz. The both of them are very important persons in forming the differential equations, Newton and Leibniz. In order to solve problems in geometry and physics, it played a crucial part in the development of Newtonian physics by the Bernoulli family, the Euler and others. That the Euler is that very important person developing many concepts for the mathematics. That's why the Euler is called the father of the mathematics. Sometimes even Newton is a base one, and then Euler developed that many concepts, particularly in the change of order of differentiation. So some of the application of differential equations in our daily life are found in mobile phones, motor car, air flights, weather forecast, internet, healthcare, or in many other daily activities. So in this chapter, we are going to study only the ordinary differential equation, and then some methods we are going to find the solution. What is called the differential equation? How to find that order and degree? That everybody already you have studied about that order and degree, but apart from that, we have to discuss order of the differential equation is very simple. And then when you are finding the degree of the differential equation, many of them have done a mistake in this. So what is a differential equation first? A differential equation in any equation which contains at least one derivative of unknown function, either ordinary derivative or partial derivative. Either it contains the ordinary derivative or partial derivative. For instance, let y equal to f of x, where y is a dependent variable. F is the unknown function. Already mentioned, na? What is f? F is an unknown function. Y is a dependent variable and x is an independent variable. The equation dy by dx equal to 0 is a differential equation. The equation dy by dx equal to sin x is also a differential equation. Any one of the equation, if the right hand side equal to 0, then it is called the homogeneous equation. Please keep it in mind, homogeneous equation. Homogeneous equation means, last class I have given one more definition for homogeneous equation. That is one more definition. Here, in case any one of the differential equation, in case dy by dx equal to 0, then it is a homogeneous equation. In case dy by dx equal to some function of x, dy by dx equal to some g of x, but g of x is not equal to 0, that is called the non-homogeneous equation. We will discuss both the cases, the solution to find the homogeneous and non-homogeneous equation. Second one, the equation dy by dx equal to sin x is a differential equation. Actually, this type of equation is known as the transcendental equation. Transcendental equation or trigonometric differential equation. The next one is, see, the dy by dx plus y, 7x plus 5. So right hand side is not equal to 0. These are non-homogeneous differential equation. So these are the few examples for the differential equation. See, here also you can see that even we can write as log dy by dx, e power dy by dx, sin of dy by dx also we can write it. It is also the differential equation, but it is not the simple differential equation. It is called the transcendental differential equation. Even see that in the tan inverse also the dy by dx is there. So this is also the differential equation. So in many types we can write the differential equation. See that what is called the differential equation basic definition: the equation which contains that one or more partial derivative or ordinary derivative, it is called the differential equation. So the equation contains that three things. One is that unknown function, second one is dependent variable, third one is independent variable. So what is the order of differential equation? Next one. The order of the differential equation is highest order of differential equation is highest order derivative present in the differential equation. Thus, if the highest order of the derivative is unknown function y, which is the kth derivative, see that here. In case d cube y by dx cube whole power 2 by 3 minus 3 d square y by dx square plus 5 dy by dx plus 4 equal to 0 is a differential equation of order 3. Then degree of the differential equation. Order of the differential equation is very simple. We can write very simply. We can write that. But order of the differential equation only we have to concentrate. In a differential equation is expressible in a polynomial form, then the integral power of the highest order derivative appears is called the degree of the differential equation. That means, so here whole power 2 by 3 is there. Actually d cube y by dx cube, here the order is 3, degree is 2 by 3, but degree is 2 by 3 means it is meaningless. It will not come. So it should be that integer. The degree should be that integer. That you have to convert into that integer degree. Otherwise, we are not able to define the degree of the differential equation. Then what are the rules of the to find the degree of the differential equation? We will discuss point by point. The degree of differential equation is the power of highest order derivative involved in the differential equation when the differential equation, after expressing the polynomial form, satisfying the following conditions. What are the conditions to find the order of the degree of the differential equation? All of the derivatives in equations are free from fractional powers. That is one important point. If any fractional powers is there, you have to make it that integer power. Then highest order derivative should not be an argument or transcendental function or trigonometric or exponential, etc. Highest order derivative, if some highest order derivative is there. For example, here, see this equation. What is the highest order here? 2 is the highest order. And 2 is the highest order, but we can't able to write that 1 is the degree here because it is the transcendental equation, the trigonometric equation. So if it is in the trigonometric equation, we are not able to write that order for this. But sorry, we can write the order for this. We are not able to write the degree. So one more condition is, so what is the condition here? The highest order derivative should not be an argument of a transcendental function, trigonometric or exponential. The coefficient of any term containing the highest order derivative should just be a function of x, y, or some lower order derivative, but not as transcendental, trigonometric, exponential, logarithmic function of derivative. Okay. Any doubt in this page? Please go through that once again. Any doubt in this page? If there is no doubt, I can go to the next slide. Can you go to the next slide? So, if the differential equation is not expressible to a polynomial equation form having the highest order derivative is a leading term, then the degree of differential equation is not defined. For any differential equation, we can write the degree, but sorry, we can write the order. For any differential equation, we can write the order, but all the differential equations, we are not able to write the degree. Sometimes the degree of the differential equation is not defined. So in the last page, I have given all the conditions whenever we are not able to define the degree of the differential equation. So the determination of degree of a given differential equation can be tricky if you are not well versed with the conditions under which degree of the differential equation is defined. So go through the given solved example. Some of the solved example we can see that example for calculation of degree. See that consider the differential equation 3y square dy by dx whole cube minus d square by dx square sin x square. So here that d square y by dx square is the highest order and then degree is 1. We can write very simply. But in case if it is some decimal powers are there, we have to make it as a integer. Then only we can find the degree and the order. Consider the differential equation square root of 1 plus dy by dx whole square plus equal to y into d cube y by dx cube. Since the equation involves the fractional powers, we must first get the root of them on squaring equation on both sides. When you are squaring equation on both sides, we will get that 1 plus dy by dx. So if you are put the square here on both sides. So here also you are squaring that. Then you will get that 1 plus dy by dx whole square equal to y square d cube y by dx cube whole square. Now we can clearly make out that highest order derivative is 3. Therefore, order of the differential equation is 3, and since its power is 2, therefore degree of the equation is 2. So this type of problem is somewhat tricky. Next one is third one. See that consider the differential equation sin of dy by dx plus d square by dx square plus 3x equal to 0. Here the highest order is 2 because the sign of first derivative. In case if it is an sign is not here. In case sign is here. Sign of d square by dx square something is there. This is here. Then it is that order is 2, but the degree not able to define. Here also we can see that the highest order of the derivative 2 because the sign of first derivative, the given differential equation cannot be expressed as polynomial equation. This is very, very important. We are not able to express it as polynomial equation. So the order of the differential equation is 2, but the degree is not defined here. Here also see that it is an exponential equation. E power d square by dx square plus sin x dy by dx equal to 2. Here the highest derivative is 2 as involved in the exponential function. This cannot be expressed as a polynomial equation d square by dx square as the leading term. So the degree of equation is not defined. The order is 2. So these are the few cases we are doing here. So a few examples you can see here. See the fifth one. Fifth one is differential equation. Kavin, are you there? Kavin,
சார்
இருக்கீங்களா?
இருக்கேன் சார். நெட் கொஞ்சம் ப்ராப்ளம்.
நெட் ப்ராப்ளமா? சரி, ஃபிஃப்த் ப்ராப்ளம் வந்து ஆர்டினரி டிஃபரன்ஷியல் ஈக்குவேஷனா?
சார்
ஃபிஃப்த் ப்ராப்ளம் இப்ப எக்ஸாம்பிள் பாக்குறீங்களா? ஸ்கிரீன் பாக்குறீங்களா இல்லையா?
தெரியுது சார். ஃபிஃப்த் ப்ராப்ளம்.
ஃபிஃப்த் ப்ராப்ளம் வந்து டிஃபரன்ஷியல் ஈக்குவேஷனா இல்லையா?
ப்ராப்ளம் டிஃபரன்ஷியல் ஈக்குவேஷன் தான் சார்.
டிஃபரன்ஷியல் ஈக்குவேஷன். சரி, அதனுடைய டிகிரி என்ன?
1.
டிகிரி 1.
டிகிரி
ஆர்டர் 1. ஆர்டர் 1. ஆர்டர் 1 டிகிரி 1.
சார்
இதுக்கு டிகிரி எழுத முடியுமா முடியாதா? இப்பதான் சொன்ன லாஸ்ட் now only I explained how to find the degree and order of the equation. Hmm? Now only I explained how to write the degree and the order of
The
the
voice
equation.
break out, sir.
Voice break.
Yes, sir. Voice breaking, sir.
Okay, mic off. In case, see here, determine the order and degree of the following differential equation. So here, one by one, we can explain the. See that first problem. dy by dx equal to x plus y plus 5. So in this equation, the highest order is dy by dx whose power is 1. That's okay. So here that order also 1, degree also 1. See that the second problem. In the second problem, d power 4 y by dx power 4 whole cube plus 4 dy by dx plus 6y equal to 5 cos 3x. In case x involves in the transcendental function, then we can express it as polynomial. We can express that polynomial. In case the transcendental function, cos trigonometric functions involves y involves in trigonometric function or logarithmic function or exponential function, we are not able to express it as a polynomial. That is one important point. So here we can see that because here also that x is involved in sign, but multiplication with y. So here we are not able to write that. Degree is not able to define. But here the x is only involved in x. It's not multiple with y. So we can write as, see that power is 3, that means order is 4 and degree is 3 for the second one. Only thing is you have to see that all the 5 problems, what are the difference between them, you have to identify that. Even see that fourth problem. In the fourth problem, they have given that whole power 3 by 2. If you are squaring on both sides, you are also squaring that, the 2 get cancelled. The fourth problem, 2 get cancelled. Squaring that on both sides, 2 get cancelled. Now, see the d square by dx square whole square. So that order is 2, degree also 2. In the third one, you can see the third one. Third one, what is the order, what is the degree? ODE இருக்கீங்களா? ODE இருக்கீங்களா? இல்லையா? அக்ஷயா?
Yes, sir.
Voice break is Akshaya.
Yes, sir.
For the third problem, what is degree, what is order?
Order is 2 and degree is also 2, sir.
அதான் தப்பு. இந்த இடத்துல லாக்ல வந்திருக்கு பாரு, d square by dx square is in log. Right hand side la d square by dx square is in log na?
Yes, my sir.
So the degree is not defined here. See the third one answer. Third one answer is, see that in the given differential equation, the highest order is d square by dx square. The order is 2. But the given differential equation is not the polynomial equation, it's derivative and its degree is not defined. Degree is not defined.
Okay,
so
sir.
see the difference between that, how you difference between the problems. Whether you can express as a polynomial, then we can write the order and degree. If you are not able to express it as a polynomial, then only order can be written. The degree not able to write. The degree is not defined for this.
Okay, sir.
Okay. Thank you. Mute பண்ணீங்க.
Okay, sir.
So classification of differential equation. The classification of differential equation, there are 2 differential equations are there. One is, you know that what is the ordinary differential equation, what is the partial differential equation. If your differential equation contains only ordinary derivatives, then it is called the ordinary differential equation. These definitions you have to remember. An equation which involves the partial derivatives of one or more functions of two or more independent variables is called the partial differential equation. For instance, let y denote the unknown function and x is the independent variable, then dy by dx plus 2y e power minus x. See, this equations are involve only the ordinary derivative. It is not only the dy by dx. See this problem. See this equation. It contains both x and y are the dependent variable and t is the independent variable, common independent variable. Then we can write this as a ordinary derivative differential equation. So and then see that last one, this dou u by dou y equal to minus dou u by dou x, dou square u by dou x square, dou square u by dou y square equal to 0. It is a Laplace equation. And dou square u by dou x square plus dou square u by dou t square minus 2 dou u by dou t is a parabolic equation. That is when it is a parabolic, when it is a elliptic, when it is a hyperbolic, and you have to go through that in the online. You have to go through when the partial differential equation is said to be that. Please note down that when the partial differential equation is said to be parabolic, elliptic, and hyperbolic. Please go through the notes in the internet. I will ask the question in the next class. Please note down that classification of partial differential equation is the topic actually. Apart from the syllabus, it is a very simple topic. Classification of partial differential equation. When it is said to be the parabolic, when it is said to be the elliptic, when it is said to be the hyperbolic. This is very, very important topic in the differential equation. Next one, see that the general form of the ODE. The general form of the ordinary differential equation, please write down this. This one you can write. The general form of the ordinary differential equation of order n in any differential equation that can be written in the following form. A n of x y power n plus a n minus 1 x y power n minus 1 plus a1 of x y dash plus a naught y equal to g of x. Where y power n is not y power n, y of order n. That means it is e power n y by the x power n. In case if I write that d by dx is capital D, then what is the general form of ordinary differential equation? Renuka Devi. Renuka Devi. இருக்கீங்களா? M. Renuka Devi. யுவஸ்ரீ இருக்கீங்களா?
சார்
எஸ் சொன்னது யாரு? ரேணுகா தேவியா யுவஸ்ரீயா?
யுவஸ்ரீ சார்.
சரி யுவஸ்ரீ. இன் கேஸ் d by dx equal to d நான் எடுத்துக்கிறேன். அப்ப இந்த டிஃபரன்ஷியல் ஈக்குவேஷன் எப்படி எழுதலாம்? வேற யாராவது? குயிக்காமா டைம் இல்ல
சார்.
கொஞ்சம் ஃபாஸ்டா ஆன்சர் பண்ணுங்க.
டி
சொல்லுங்க.
d nth derivative of y.
Okay. எழுதிக்கங்க. an மவுஸ்ல எழுதுறதுனால கொஞ்சம் சரியா வர மாட்டேங்குது. an of x d power n y plus அடுத்தது என்ன? ஒன்னு எழுதிட்டேன், அடுத்து சொல்லுங்க. a n minus 1 x அடுத்து d power
d power n minus 1
n minus
d power n minus
y
1
power n
y power n எல்லாம் கிடையாது, y தான் வரணும். ஏன்னா இதை என்ன பண்றோம், d by dx equal to d னா d by dx தனியா எடுத்துக்கங்க, இதை மட்டும் தனியா எடுத்துக்கங்க. அப்ப இது என்ன ஆகும், d power n y n ஆயிடும், d power n y n ஆயிடும். சரியா? அதே மாதிரிதான் பிளஸ் எக்ஸெட்ரா up to last term a naught y equal to g of x. Okay, so this is the general form. In the symbolic format is f of d y equal to g of x. This is the symbolic format of ODE. F of dy g of x is the symbolic format of, put one important point on. F of dy equal to g of x, where a naught a n, see this is the important point, where a n of x, a naught of x, a n of x ds are the function of x are constant. The coefficients are there. The coefficients are maybe the function of x or constants or transcendental function in x. Did you complete that page? Can I go to the next slide? Anybody is not completing this? Next one is write the notes. No need to write, just listen. The important thing, the note about the linear differential equation is that there is no products of the function y of x and its derivative, and neither the function is not its derivative occur any power of that is other than the first power. That means it is not product in case y power n minus 1 y dash y, it should not be multiple with y here, it should be the function of x. All this a naught a n, these coefficients of d y power n minus 1 y, every coefficient should be the function of x or constant. It should not be the function of y, should not be the function of y. Okay, and then its derivative, see, no transcendental function or trigonometric logarithmic of y or any of its derivative occur in the differential equation. Also note that neither the function nor its derivative inside the another function, nor its derivative are inside the another function, for instance root of y dash or e power y dash. See, the coefficients a naught of x, a1 of x, a n of x, g of x can be 0 or non-zero or constant. So the last slide I told now that may be the constant or function of x. Linear or non-linear function, only the function y of x and its derivative are used to determining whether a differential equation is linear. I will explain clearly what is called the linear and non-linear in the next class. Okay, when it is said to be the linear, when it is said to be the non-linear, how to solve the linear differential equation, how to solve the non-linear differential equation, then everything I will explain in the next class. Okay, so next class we will discuss all these things. In the class, we have discussed about that, what is called the ordinary. Once again, I go through that. What is the ordinary differential equation? What is the motivation? And what are the developments in that ordinary differential equation? Second one is what are the few simple examples for the ordinary differential equation? And then what is the real life problem to form the ordinary differential equation? And then what is the order and degree of the differential equation? Okay. So, and then we have discussed a few examples in order and degree of the differential equation and what are the classification of differential equation. And then I have given one assignment to you. What is the assignment? Renuka. D Renuka இருக்கீங்களா?
When the partial differential equation is said to be parabolic, elliptic, and hyperbolic.
Very good. So this is the assignment to you. In the next class, I will ask the question based on this. Everyone has to ready to answer for this, answer for my questions. Okay. So now I think that I'll stop sharing my slide now. Today is 6. Vijay. Vijay Ilya. Your stream. Your stream. Rahvi.
Yes, sir.
Bhargavi.
Yes, sir.
Okay. Mala.
Yes, sir.
Monisha.
Yes, sir.
Okay. Shilo Saran.
Yes, sir.
Akshaya.
Sir.
Madhumita.
Yes, sir.
Ramya. P. Ramya. Ramya. Shanmuga Priya.
Sir.
Jagbolan.
Present, sir.
Jagbolan Alinger.
Yes, sir.
Oh, yes, sir. Okay. Kavin.
Sir.
Kavin. Okay. Lakshmi. Lakshmi ಇಲ್ಲ. ಹೂವಿಳಿ. ಹೂವಿಳಿ. ನರ್ಮತಾ.
Yes, sir.
Ebenezer. Ebenezer. Padmapriya. Padmapriya.
Yes, sir. Yes, sir.
Renuka Devi M.
Yes, sir.
Renuka Devi. Renuka D.
Yes, sir.
D Renuka.
Yes, sir.
Oh, அங்க இருக்கு. Yours T. Ajita. Ajita.
Yes, sir.
Okay. Sivappa. Yes.
Yes, sir.
Okay. See, today absent is 4 absent is Vijay, Ramya V, Lakshmi, and then Kovidi.
Sir,
Yes,
Lakshmi, I am present, sir.
Lakshmi present. சொல்லலையே.
Speaker.
Work பண்ணல. Sorry. Okay, fine. So, any other things? You know that I am the class in charge for your class, and then I will fix that your counseling hour. Every week one counseling hour is there. I will refer your timetable, and then day order one. I think your day order one. Is there any free hours are there? And this that's it. Don't leave the class. Please here. You can see your timetable now.
Second are free, sir.
Wait for a minute. Just wait for a minute. Odd. M.Sc Math. Okay. So see that this is your timetable. Second hour 10 to 10:43. In the second day order, I am having the class. This class I am having, so not able to take. And then here fifth day order. First hour is free. 9 to 10. So we can fix that. First day order, second hour is the counseling hour for you. So in the counseling hour, we will discuss next class. We will introduce ourselves, everyone. Even I will call all the teachers who are handling your class. I will call all the teachers to the meeting. Then you have to prepare at least 2 to 3 minutes for the introduction. The next class, at least 2 minutes you have to take for the introduction of yourself. Okay, fine, ma. See you in the next class. You can leave the classroom. You can leave the class now.
Thank you, sir.
Thank you, sir.
Thank you.